Now. So this chapter really has two topics: types of reactions and then how to speed them up or slow them down. Okay? For the types of reactions, you need to know these 6. Okay? So the first we started was synthesis, which looked like this. A plus B gives AB. The opposite of synthesis was decomposition. AB gives A plus B. And what I really mean is single element plus single element gives compound, and compound plus gives single element plus single element. Okay? Okay, that works, although there's also 2 others that begin with S and D, but they have the word single and double. Okay? Then we had single replacement. And it sort of goes with double replacement. In fact, I'll do them both at the same time so you can see the pattern. For a single replacement, the solo guy bumps one of the other guys. So it can be AC plus B, or it can be BC plus A. It depends. The metal bumps the metal, the non-metal bumps the non-metal, and you know enough on your periodic table now that you know, oh, the non-metal. You know the difference between the non-metals and the metals. So the metal bumps the metal, non-metal bumps the non-metal. Double replacement. You have 2 compounds. Oops. And they trade partners. So A goes with D and C goes with B. Now I wrote it in that, I wrote the second and the first one in that order on purpose. I didn't write them alphabetically. Instead, I said, you know what? A is the metal, metals go first. C is the metal, metals go first. Okay? I don't know if I'd take marks off if you wrote them in the wrong order, wrong partners. I'll take marks off, but let's get in the habit. It's always metal, non-metal. Okay? Now, often both of the reactants, which is the left side, were what an AQ stand for. Do you remember? Okay, yeah, in an aqueous solution, which is in water. Need a bit more room here. Make the chart a little bit bigger. One of the products was a precipitate, solid. So you poured 2 liquids together, and I didn't do a good demo of this because this is all kind of before and after Christmas, but you pour 2 liquids together, you shake them up, and you may notice if you then let it sit for a while, oh, a powder is a powder in the liquid, so not a dry powder, but something solid is gathering on the bottom, and there's a liquid on top. You call the bottom solid a precipitate. I think I just gave you a hint about a possible vocabulary word you might see on Wednesday, the word precipitate. Okay? There's also a dumb chemistry joke. It says if you're not part of the solution, then be part of the precipitate. Boom, boom, right? Neutralization. I'm not going to put the word reaction. I'll just put the word neutralization. This was Rylan, what was the result? What do you get when you mix an acid and the base?
Salt and water.
I'm doing that. I picked on the same person on purpose because that's one more way to trigger the memory, right? You're remembering the. Oh, I know what he said. Salt plus H2O. Whoop. Oh. How do I do a subscript? Is it going to be that? Nope. Is it going to be that? Nope. That. Okay. Okay. Now remember, how do you recognize an acid? More specific. It got to be, no, not quite. Okay. It's not an HO at the beginning. It is how it starts. Now, by the way, have you got a periodic table handy? Can you just pull yours out, Sage? Okay, you got one, just so you each have one to look at with your groups. Look at the back. See the acids in the top right. Okay, that's one way. Do you have the yellow acid sheet at all handy?
Got it right here.
Okay. Look at in the top half, the chart where it shows acids and base, not the bottom part, but the actual picture. What does it have in the top left corner? H plus. What does it have in the bottom right corner? OH minus. So it kind of tells you base ends in OH, and that's why it's on that, and starts with H. So I'm going to write here H, acid plus something, plus B ending in an OH. Okay, it's a negative ion, but the negatives don't appear in the actual formula. Results in, and then what happens is B. Why did I write the B? Because the B is the non-metal, B is the metal, A is the non-metal, plus H2O. Okay. This is technically a double replacement because if you look, they change partners, sort of, but not quite, but sort of. And then the last one, which I keep saying composition for some stupid reason, because it's decomposition up there, and that's in my brain. Combustion. Burning. Okay? And this is a hydrocarbon plus O2. Gives CO2 plus H2O. You have to memorize the product, and if you see that as a product, you know the left side must have been a hydrocarbon plus O2. Now, what do I mean by a hydrocarbon? Okay. Hydrocarbon has a carbon with something beneath it, a hydrogen with something beneath it, some subscript, and it may or may not have an oxygen with some subscript. So, from last unit, if it had a CH and an O, what was that? Alcohol. So it can be burning alcohol. When you burn alcohol, when you light it on fire, it gives off carbon dioxide and water. In fact, it can be very dangerous. There are alcohol stoves, camping stoves that use alcohol. You can't use them in an enclosed, non-ventilated area. You can get carbon dioxide poisoning. Okay? Carbon dioxide and water, and it removes the oxygen from the air. Yep. If it's just a CH, we called that a hydrocarbon. Alcohol was a CH and an O. Okay? These are tricky to balance, but you know the products. So that's kind of the 6 main reactions. What types of things? Now, be honest with me. Are you guys getting okay at the balancing of an equation if you have everything in front of you? In other words, if they've done the crisscross and everything, are you getting okay with we've been doing the basics as well, and right? And by the way, again, on the test, I have no problem if you carefully list them out the way I did initially. I also have no problem if you're getting comfy enough to keep track of it up here. Honestly, on a test, I probably would still list them out. In my homework, yeah, I want to get fast, right? I mean, it's called getting good. So if you're okay, what I'm going to then talk about, since you're okay with the balancing, is I'll show you some questions where we're predicting the product, doing the crisscross, and then doing the balancing. That does not mean that's most of the test. In fact, most 12 marks, I think it's 12 marks, is I'm giving you 6 equations, probably one of each of these, but maybe not, where they're completely written out. You have to balance and identify. Okay? 6 more marks is predicting the products but not balancing. 3 questions or 2 questions is predicting the products and balancing. So let me show you what I mean. Okay? So classify and balance. Here, I gave you some of these. I'm going to go to where we're actually predicting the products. Oh, I gave you these as homework, okay? Word problems, I think there's a couple on the multiple choice only, and then I put one written as a bonus where I give you a word equation, and I'll do one like that with you right now, because this is about as tough. Actually, I'll do one in a few minutes, because this is about as tough as it gets. Let me do one that has symbols first, where we're predicting the products. Okay? I think here I said do the odd letters, so I'll do an even letter. B, D. Sure, let's do D. And this is the nice thing with this. I can go clip. And this is what I'll print for you guys after. First question. What kind of reaction is this? Is it a synthesis? No. Are we burning? Is it combustion? No. Okay? It's either double replacement or neutralization. If it was neutralization, what would I see here? Acid and base. Okay, so it's a double replacement. So what's going to happen for the products here, Julia, is, look up, that's going to bump that. Okay? So the product is going to be AgPO4 and NaNO3. Now I need to crisscross still. The subscripts might be totally wrong. Hang on, let's pause here. I've almost certainly crisscrossed wrong because, Julia, I doubt if it's going to be 1 and 1, 1 and 1. Let's do this one first. On you guys got a periodic table accessible? What's the charge on sodium? What's the charge on Na? Sodium's a metal. Okay, it's on the left side. It's element number 11, is it? I think, yeah, plus. Now, NO3, that's a polyatomic ion. Hopefully you're all flipping your periodic table over already, right? What's the charge on NO3? It would be great if it was also just minus, just straight minus? Oh, so this one is 1 and 1, but am I going to write the ones? No. Here, nice. What's the charge on Ag? What is Ag?
That is silver, and it's a poly.
Is silver multivalent?
Yeah.
It's not. Oh, whew. Sorry, I glanced at this and I thought it was Au gold, which is multivalent, and I thought this was going to be yucky. No, silver. What's the charge on silver?
Just positive.
Just plus. And then there's a PO4. What's the charge on the PO4? Polyatomic from the back. 3 negative. So, up here in my actual equation then, Julia, this is what we mean by crisscross. Look up, kiddo. That goes there, that goes there. But I'm not putting negatives. All I know is, you know what? Apparently I need 3 of those and only 1 of the PO4s. This would get you not balanced, but this is the crisscross part. And so there is part of the test where I give you the left side and I just say, yeah, tell me what the right side would be, but don't bother balancing. Okay? Now we balance. Oh, sorry, what did you guys say this was? A double replacement? Let's do that. I should write that in.
So the question I guess would be out of 2?
2 or 3, I can't remember. You know what? This whole thing would be out of 3, but I think I only put 2 like that. What I actually did is I gave you, I think it's 6 questions, where all I say is, tell me this, don't balance, and identify. 1 mark for the tell me, and 1 mark for the what type. Okay? Then there's some questions where I give you this crisscross, and I say balance, tell me the type. There's 6 of those, which I think is 12 marks. Then I have a couple of questions where I say, okay, tell me this, crisscross, balance, and type. But I only put a couple of those on there. Test is out of, I think, 63 or 55 or something like that. It is and it isn't, because if you can identify the reaction types?
Yeah.
That's about 15 marks right there. If you can do that, about 1/4 of the test, you'll ace. Okay? If you can tell the difference between a single replacement, a synthesis, a double replacement, a neutralization, a combustion, and the one that I've forgotten that I'll remember after I stop thinking of decomposition. I always forget that. Okay? If you can do that. Then there's about another 15 marks or so. Sorry?
Yeah, putting down composition, because I wasn't thinking about synthesis.
It's the opposite of synthesis. I just, honestly, I think decomposes. Like, I remember, I think of something rotting, splitting apart. That's what decomposing is, right? There's about another 15 or so marks is going to be the, can you understand whether temperature increases or heating up increases? Yeah, we'll get to those as well. But it's not as bad as you think. Like identifying the types, I'm hoping that takes kids about 10 seconds apiece. That's kind of what I'm budgeting for those 15 marks. Okay. Anyways, let's keep going here. Let's balance. What doesn't balance? Do you guys want me? I'm going to erase. I shouldn't have erased that. Let's leave that because you guys want that for work. Do you want me? Do you balance these now in your head, or do you want you still make a list like I've done before? Okay, I'll make a list. Okay, Julia, how many AGs on the left? How many AGs on the right? So I would go like that. What else has that changed? How many NO3s? Because now there are, it used to be one, but now there is. So I would go like that. And now that gives me, oh, and that's also changed, nah. Oh, ooh. How many on the left? How many?
3.
In fact, you know what? I heard Sage murmur, we're balanced. And if you suddenly spot that we're done, you don't have to write all the gaps. I'm not marking work anymore, okay? Is that all right? Let's do another one. Let's see if I can find a nastier one. Because ideally, this lesson should be... Here, L. Not quite, but close. What kind is this?
Combustion.
How can you tell? That twigs it, and there's a hydrocarbon. That might be an alcohol, although it looks a bit weird for an alcohol, but I think it's probably some type of alcohol. So combustion, hey, you just got 1 mark. Predict the products. This is not predicting. This is the only one I've said you need to memorize. When you burn something, what do you always get? And I've actually taught it to you. You've memorized the crisscross part. You don't even need to do it anymore. So there's 1 mark. Now we balance. This is tough to balance, especially the O's and the H's. So I saved them for last. What are you going to start out with then? How many C's on the left?
2.
How many on the right? Right now, 1. So I put a 2 there. Now let's change a bunch of other stuff. Save the O's for later. And the reason I save the O's for later is they're always going to be in 2 locations. At least the H's on the right are going to be in 1 location. So let's do the H's on the left. How many H's on the left? 6. Strangely, but yeah. How many H's on the right?
2.
How can I fix that?
You can just 3.
If we're lucky, either the O's will have taken care of themselves or it'll be a fairly easy fix. How many O's on the left?
3.
Yeah. How many O's on the right? 4 plus 3. How many? 7. 4, 4, and 3. By the way, common mistake, of course, kids think that 2 is on the O, right? Don't do that. Hopefully we move beyond that, and you guys are doing much better. 7. How many over here? 3. How many right here? Just here. 1. So if I want 7 over here, can I turn that into? That would give me 8. I got 1 here.
Turn that into 6.
What?
Turn that into 6.
Turn it into a 6? How?
What if you-
Yeah. And that's why these are tough, because you're splitting up often one of the compound, oxygen. Okay? I don't have a good way to make those ones easier. At the same time, I sit around campfires all the time, and there is a part of me as an inner nerd saying, oh, carbon dioxide and oxygen. Yes, really? Yes, really. Don't take this wrong. I like burning things, not in a creepy arsonist way, but a good campfire on a summer night.
I'm a pyromaniac.
Pardon me?
I'm a pyromaniac.
You're a pyromaniac? Okay. Move over. Move over. Yeah. Fire extinguishers over there. Okay. Are you okay on the predicting and the product? Feeling a little comfy?
Yeah,
Okay. So, and Matt, I'm going to guess you probably don't need to memorize these 2, the single and double replacement, because they kind of make sense. Replacement means swapping. Single, oh, 1 thing bumps. Double, oh, 2 things bump. Okay?
First 4, very easy.
These 2 are the tricky ones?
I like
Okay.
combustion.
Okay, see, so he's got burning. That sounds wrong. That sounds like you're going to your doctors and telling them that. Okay. Am I going to give you a word one? I said I would try one to show you how tough we can get. Okay? So, please tell me that's on there. It's not. Let's try J. Is there more than that? Yeah, let's try J. Here is word to product to balance. I give you one like this as a bonus, but each subpart of this is going to be fair game on your test. First of all, look at this. What is this? What type of reaction? Imagine the symbols. Imagine how many of each there are in each chunk and figure out what makes it work. Iron 2 sulfate plus calcium hydroxide. What must... Iron 3 sulfate, sorry, thank you, plus calcium hydroxide. Is that a single element combining with another single element? Is it synthesis?
Double. It's a
Double replacement. It's a doctor. Double replacement, right? Okay. Hey, you got one mark. Now I would make the left side symbolic. What's iron? Symbol. Fe. What's sulfate? Not sulfide, sulfate. Sulfide is the element. Sulfate's one of the ones on the back. It's going to be SO3 or SO4 or SO2. SO4?
I can verify that.
Now I need to crisscross to get the subscripts. What's the charge on iron?
Charge on iron would be...
Iron is multivalent, right?
3 positive.
Or?
3 positive, 2 positive.
Wait a minute, which one am I going to use? By the way, you didn't need to look up the charge on iron. They told you. Which charge do they want me to use?
4.
See, now it's all coming together. That's what that meant, okay? That's okay.
I looked at it.
It's okay. You got the I.
I don't usually laugh at you.
Bonson Park, 4 o'clock. If I'm not there, start without me. Let's keep going. What's the charge on,
2 negative.
sulfate is 2 negative?
Yeah.
Okay, so I can now say Fe2 SO4 3. You okay with that, Ty? Okay. By the way, you guys have come a long way because a month and a half, all 4 of you on that first test would have been going, say, what? Now, this is where I said, you're closer than you think. I've got each piece swirling around in your brain. What I need to do is just put it all together. You guys are so close to acing this. So close. Yeah, you got more in there than you think.
Yeah, but still not enough.
We're getting there. Plus, symbol for calcium is Ca. Symbol for hydroxide is OH. Now I need to crisscross. What's the charge on calcium? What's the charge on OH?
It is,
I think it's just 1 minus.
it's negative.
So when I crisscross, you got to go. Okay.
No, I just got
Oh.
my thing out. I didn't-
Okay. When I crisscross, it looks like I'm going to have 2 OHs. And let me be consistent in my color here. So we had 2 and 3 of those and 2 OHs. Now, let's predict the product. What did you say this was? So these 2 are going to swap. Okay?
Those two.
The 2 metals always swap. Okay? Well, I mean, or you can say the 2 non-metals swap as well, but what I'm saying is they're going to switch partners no matter what. Is that okay? So it's
Which one was first, though?
which it doesn't matter which product I write first, but in each product put the metal then non-metal because that's how we write compounds.
What if you write it in practice at all? Or half
It's
practice?
bad math. It's bad chemistry manners. Is it wrong to walk around with something hanging from your nose? No. Do you want to have friends? Deal with it. Do you want to have chemistry friends? Deal with it. Okay?
What if you're wrong? That's what I'm asking.
Would it be wrong? Yes. Will I take marks off if you write a non-metal and then a metal? No. But I'll give you the frowning of a lifetime.
Okay.
Yes.
Will we get marks off when we don't put the brackets?
Yeah. Like around the SO4? Yeah, because otherwise, here's what you're saying. that 3 now you're saying is only on the oxygen.
So do you put anything in the brackets that's on here?
Yep.
Okay.
If there's more than one of them.
Okay.
Okay?
You know when you need to put brackets on
If there's more than one of them, if it's a polyatomic ion, and there's more than one of them. So what are the polyatomic ions? Back page. The back page.
Okay, so
Okay?
all these-
By the way, for what, the back page, but not the acids in the top right, right? The polyatomic ion column, right? Can I keep going? And you'll see, I think it'll become clear again. Ready, 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 ready? So, look up, look up, look up, look up, look up. It's going to be FeOH, but I haven't crisscrossed yet. And it's going to be CaSO4, but I haven't crisscrossed yet. Guys, I need you here. It's going to be, right, there's the double replacement portion, but now I got to crisscross. What was the charge on iron? I don't need to look it up. They told me which charge to use for this, okay? 3, and what's OH? Negative, okay? When I crisscross, you asked, when do I have to use the brackets? How many OHs am I going to need? 3 OHs. That's when you use the brackets. Oh, and 1 iron. Am I going to put a 1? Okay. Ca, you said was 2 plus. SO4, you said was 2 minus. Oh, that one crisscrosses wonderfully into, well, technically 2 and 2, but we reduce 1 and 1. There, that would get you 1 mark.
Would you put the brackets or not?
I'll need one of them. I mean, you could say this, but
For like the final answer.
for like the what?
For the final answer, you'd use the brackets on SO4.
This is the final answer so far. I'm not sure what you mean.
So would you put brackets on SO4?
No, because there's only one of them.
Oh.
That's what I'm saying. How many SO4s? It's 2 and 2, which is 1 and 1. So there's an invisible 1 down there, but that's like saying, do you put a 1 in front of an X? Not if it's by itself. We understand it's there. Is that okay?
Yeah.
Now we balance. Ready, Julia? We're going to balance. We're going to balance without showing work. Start with the FEs. How many on the left? 2. How many on the right? So I definitely have to put a 2 there. Right? Okay. What did that just change? This. Originally there was 3. Now how many are there of the OHs? 6. How many of the OHs here? How can I make that 6? Good. What did that just change? CAs. How many CAs are there on the left now? How many are there over here? I better put a 3 there. And no, I think we're good. Because how many SO4s now do I have on the right? 3, and there's a 3 right there. We're good. Okay? What I'm saying is it is possible to do the, and again, if you're comfortable listing it, go ahead, because you and I were doing that the other day and you were getting them fine. But in the interest of time, because you're getting it squirrely, I wanted to cut that cord, that short. That is the portion of recognizing reactions, predicting products, balancing equations. Am I going to give you one with all 3? Not with words. I would, again, have no problem. There is going to be 2, I think it's 2. It might be 3, but I think it's 2, where I give you what's here typed, and you have to predict the product and balance and categorize. But most of it is, I'll even show you, especially on the written, it's either I give you everything balanced, I give you everything written out crisscrossed, balance and tell me the type, or I'm giving you this, the left-hand part crisscrossed, and I'm saying predict the product, don't balance, but crisscross properly. Tell me the type. There's only a couple where I ask you to do all 3. Okay? Look at the take-home quizzes that we marked today if you want more practice. And remember, there's blank copies. And I haven't put the answer key up online yet, but I'll put that on as soon as we're done this tutorial. Then we went into reaction rates. Okay? And there was 4 factors.
Temperature.
So it's temperature, And I'm going to say then, increasing temp, does that make the reaction rate? Okay, speeds up reaction. This is going to be obvious, but I'll say it. So lowering the temperature, what?
Slows it?
Okay, so here's a nice thought experiment. Alka-Seltzer pills, do they work better at the North Pole or at the equator?
At the equator.
At the equator. Okay, and it's actually, doctors have to take that into account. Or there's Alka-Seltzer pills don't work differently at altitude as well. They have to take that into account.
I haven't gotten all my
Nope. Sorry. Used to make what?
bombs out of it.
Yeah, that's a good physics. You can do them out of little foam containers.
Yeah, that's what we did. We
Yep,
shoot 'em.
and they pop up. Yep.
I think physics next year.
What was the next one?
Catalytic confusion.
Surface area. How much of the surface is exposed? And really what you want to think cutting up into small pieces. So, didn't want to do that yet.
Like kindling.
Increasing surface, can I abbreviate surface area with SA?
Yeah.
Increases or decreases? Okay? So yeah, kindling, think cutting something up, think grinding it into a powder.
Kindling.
Even we looked at, I showed you the video, steel wool can burn. Steel can burn. A big thing is steel won't burn, but steel wool has enough of a surface area that it can combine with oxygen in a combustion reaction.
Isn't steel wool used to like clean dishes?
Yeah, use it to scrub as well because it's got an abrasive quality as well. Yep. Okay. What's-
Catalytic.
Okay, we'll save the catalyst for last.
Concentration.
What many of you have trouble with.
Main-
Hey! No, okay.
That was funny.
Okay. By the way,
Left her hanging.
opposite of concentration. What's the opposite of something that's concentrated? It begins with the letter D, and I did use it today.
You're wrong. Dilution.
Okay. Opposite of, I'll say concentrated is diluted. Okay. So, here's the question. Increasing concentration, what, increases or decreases?
Increases. Lots of gunpowder, you can leave your explosion all over the gunpowder.
Sure, that's one way to think about it. More oxygen will cause a fire to burn faster. It's why when you blow on fire, stronger acid will acid the stuff faster. So if you pour water into an acid, that dilutes it. Or stronger base will pour water into a base. In fact, that's why cleaning chemicals often, like for the industrial strength stuff that they use here in the school, they pour a little bit and then they add water because the stuff in the jar is far too concentrated. It would burn through the floor, right?
So, when I was camping, there was this guy, and he sprayed Pam on fire.
Yep.
Would that have anything to do with oxygen? Because it's like compressed container.
No, it's a combustion reaction, though PAM contains some alcohol. Okay, it contains hydrocarbons. And it comes out in a very, very fine mist, so it's also a surface area issue as well. That's why there's a lot of things. If you aerosolize them, which is the phrase that you use, if you aerosolize them, that's making it into very fine mist. A lot of stuff that you don't think will burn will not just burn, but burn spectacularly, like the sawdust bomb that I showed you guys in the video, right? Coffee creamer is another one. I'll show you guys a video of that maybe a bit later on, but not I can't put a YouTube video inside my tutorial because if I post a YouTube video onto YouTube, I got a takedown notice. So, what was the last one you guys wanted me to do?
Catalytic converter. I don't know the word for it, but
Catalyst. I spelled that wrong. Catalyst. Okay. The presence of a catalyst increases the reaction rate, okay? And the catalyst, what's neat about a catalyst is it doesn't get used up. So your cars have catalytic converters. Although the catalytic converters improve, they work faster when your car heats up. Your car puts out most of its pollutants in the first 30 seconds or so when you start it up, but then as your engine heats up, Oh, heat also increases the reaction rate. So now you have a catalyst that's also pulling the pollutants out, and the fact that there's also heat that causes the pollutants to be removed faster. So you can expect on your test, I'll give you situations either as pictures or as descriptions where I'll say, okay, situation A, situation B, which would you expect to react slower? Or which would you expect to react
So the
faster?
more catalyst-
Or I'll say, okay, we tried this, then we did this, and it went slower. Which factor did we change to make it go faster or slower? Okay? What was your question? I cut you
More
off.
catalyst, the stronger the reaction.
The presence of a catalyst can get it going, and more of the catalyst, yeah. For the most part, if you have more catalyst, the reaction will go faster as well. Yes. Okay? So, give me 1 second here.